Welcome to an edited down version of the live stream that happened June 2nd, 2021, where we made some really cool parts for a good friend of mine, 3Gun Kenzie. And this was an interesting one where we were able to design and 3D print the part in one live stream. So if you want to talk about art to part, this is the video to watch. Enjoy. Let's hop right into Fusion and let's get down to it. Alright, we got little Grant up now. We are taking a look at some of our design constraints. So, this product is, and I'm going to try to spell this out to you without showing you, because showing you is a little bit weird. But this is for someone that does 3Gun. 3Gun is 3 different types of guns in a competition. Just deal with it. It's an American thing, Allison, alright? I know you're going to ask me about it. It's an American thing. Don't worry about it. But when you start the competition, all firearms must be unloaded, particularly the pistol. However, that magazine that goes into the pistol first does not need to be in a holster. And it is tradition that a lot of the shooters put them on magnetic holsters. However, the magnetic holsters have a few weird problems. One, the dude that makes them kind of sucks. Very expensive, and from what I could tell, didn't know what he was doing on Etsy. So, Kenzie made her own that is literally just some magnets. I'm going to post the link to the magnets in the chat that she is using so you guys can get an idea. She's got 2 of these magnets stacked vertically like this that she can then place her magazine onto, because these are all about speed. So literally when she is going to reload, she's letting the magazine fall out of the gun, grabbing another one and reloading it. And the next person that goes around, yeah, you know, they pick them up, right? So she is slapping other people's magazines onto this holster. But the problem is you get metal shavings and you stick to crap, and it's a real pain in the ass. I have this same problem with these flashlights, and if I had to... Did Grant bring a piece of steel? Maybe. Is this steel? No, that's aluminum. Is this steel? Ha! Steel! See? The light has a magnetic tail cap to it, which is great if you need to stick it on something and shine light down so you can have spooky... Well, that doesn't work. Here, I'll put it on the table here. So you can have really spooky talks about spooky things. Kenzie got me the magnets, so we are going to make some covers for them. And the idea here, anyways, we are going to design some covers, right? And then that way, if she gets any metal shavings, any BS on them, you can pull the covers off. And because, yes, the magnets are powerful, but they're not that powerful, the parts will just fall off of them. And we're totally fine. So she actually sent me some design specifications. The diameter is 1.5 inches, the thickness is 1/4 inch, and the space between the magazine and the slide plate. The slide plate is what she uses to take this thing on and off. It's all quick release. Basically, it's awesome American magic. It's the easiest way to describe this stuff. And it's slightly under 3/8 of an inch. So we're going to keep all of that in regard. I'm going to pull this off of your screen, and we're going to get into actually doing the design work right now. So what my technique is going to be here is I'm going to draw the outline of what I want and then revolve it around a center post. Once we're able to accomplish that, we should be okay. Now this thing is going to fit reasonably loose, so it's going to have about a 1/2 millimeter worth of play, but it's going to have a detent that will lock it. And since I know that there is slightly under 3/8 of an inch between the magnet and the slide plate, I'm going to make sure that that ball, or that round, doesn't get in the way. So, we're going to go ahead and get this design. We might add in some reliefs. It just really depends on how often she needs to remove it. Kenzie, if you're still hanging out, how often do you think you're going to be removing this plastic part? If you're going to be removing it all the time, we might end up looking at putting in some relief cuts. Or I can make it really loose so it doesn't stick on all that much. Because remember, when you pull the magazine off, it's not gonna take the plastic part with it, right? The plastic part is non-ferrous, so we shouldn't have a problem there. But let's go ahead and start and get our base dimension set out here. So we know it needs to be about 3/8 of an inch out. All the time-ish, probably yes. Not really loose, though. I'll lose it. Thankfully, these are not going to be expensive, so even if that happens, that's not a problem. And you sent me your logo, which I should pull up because I want to make sure that we can put that in there. So let me bring up my email so I can grab that. Give me just a second. All right, so we know we need to make... No, Fusion, don't do this to me. So we need to make this dimension 1/2 of 3/8 of an inch. Oh, hang tight. So 3/8 of an inch should be 0.325, but I'm just going to do it the hard way. So 3 divided by 8 times 1 inch. We're going to do all of this divided by 2. There we go. This thing's real tiny. Grant, you started the wrong way. Don't do that. No, we're starting with... Where is the thing? Diameter is 1.5 inches, so it's 0.75 inches. We have to get our diameter set because the diameter is what is... This is what constrains everything else. Now, I should have made this a construction, which is X for construction line. And now nothing can go outside unless you are talking about material thickness. So, we know that we want to make this a little bit big. So we're going to do it deliberately. So we're going to go here from 0.75. We're going to go to 0.8. 0.8 takes us to 20. I'm just going to go straight to 20 millimeters. That should give us really enough room for it to slide over. Okay, because it was 19 and some change. Now it's going to go up to 20, which should give us some space there. Anyways, let's get some of our design stuff rolling here. Alright, so we want to do... Our thickness is 1/4 of an inch. We want it to look pretty for that. So we're gonna curve the outside edge. So really, we don't got to do anything all that difficult. It's going to come up. And back to the center. So we can grab the center post here. Come up till we hit 90. And we can hit our dimension from here to here is 0.25 inches. That is literally the base of it. Bring it to there. Now, we need to make a line coming from the end of the circle to the end here. We need to go back and hit X to make that a construction line. We need to put a dimension on this. We want this to be about 19 millimeters. Okay? And that will help us set all of this up. So what this is doing while I'm waiting for my email to reload, we are making sure that the detent that we're creating is not too crazy. This will help us better identify what's going on. So I want to make sure that I create a point, I match that there, and I use my constraint, which is coincident for this line to there, which it already is, and same thing for that is already there. So now we can use our diameter tool, get a diameter, and that is more than adequate. Is that the style that you want with the big bad boy? All right. While we're waiting for that, let's keep going. We need to make sure that we have enough thickness, right? This thing needs to be thick enough that we don't have any issues. So to do that, we're going to hit O for offset. We're going to offset in the other direction. And I'm thinking because this thing is going to get the hell beaten out of it, we want to make sure that we're giving her at least 3 millimeters. This thing is going to be a bit of a chonky boy, but we need that. Kenzie, can you measure the distance that you have between the two magnets themselves? How much distance you have there? Because I want to make sure that I don't make these too big that they don't fit. So while we're doing that, I'm going to do a line from here to there. And we are not going to constrain either of these lines. L for line, of course. Yes, L for line. We're not going to constrain. Geez. Let me do a line. X for construction. Just bring it all the way up. So I can make sure that everything here is coincident. Can make sure this is coincident with that, which it is. Okay, so this the little line should be perpendicular to here. And then also perpendicular to here. Now, because we don't need to have a constraint on this. I mean, we can if we want. We can just hit a dimension tool. It's going to over-constrain it. I'm guessing, why are you mad? And, like, literally, there's probably not much more we have to do. We're going to create a revolve. We're going to grab this We're going to grab this and this. We're going to revolve it around the center axis. That gives us our main part now with the with this ball basically on the inside. I'm going to create a new body out of it. I'm going to do something that I haven't shown before yet, which is a section analysis. Section analysis lets me see inside of things, so I can actually see the thickness. Because here, that's where things are going to get caught. And I don't want that to happen. And you know what? I think I have missed something. Yes, I have. So I have to make sure that the magnet actually sits in this area here. So this 6.35 actually needs to be probably 8.5 minimum. Because we want it to fit in, but if it jiggles a little bit, it's not a problem. As long as it doesn't fall off. Hey Nadav, how you doing, buddy? We're going to come in here. We're going to make sure that we do a fillet on this edge because we want to make sure that it doesn't get stuck. We don't want hard edges. Hard edges will mean things will get stuck. That should give us enough curve. Let me go out to 1 millimeter. And so what I'm doing is I am looking at the curvature right here, this green line, and I want to make sure that it looks nice and smooth. Being smooth is what is important for this to function appropriately. I tagged the wrong person in my Discord. Alright, so we've got the fillet set where we want it. We're going to leave this, we're going to fillet this edge just a hair, like 0.25. Just a little bit. We can go up a little bit. Let's go 0.35. And this top edge here, we're going to fillet quite a bit. So maybe 0.5. Oh, no. Give me that full millimeter. And that way it doesn't catch, it doesn't hurt the hands while you're using it. So we've got that for our fillet, and we can see our body is in here. This is where your section analyses lie. I can turn that off and you go back to seeing the entire disc. But we are still concerned about what happens on the inside here. So we're making sure that we have the right diameter, we have the right height. It's going to be a tight fit, but I think it's going to work. Now, I am a little concerned about it popping off, right? Right now, if I give it a little bit of extra, she might be able to fit her finger under it. I'm going to take this all the way to 10, and Kenzie's going to have to help me figure this out, because if I take it all the way to 10, she can push it up some and pop it off with her hand. Because my concern here is, I'm going to start putting lines in here, and those lines are going to enable it to flex. The problem is, we have to print this in a really poor orientation. The way to print this would be facing straight up and down like this. Well, as you guys know, 3D printing is weakest along the Z-axis, so along this vertical axis here. She's got nails, and she can take it off the top of the top one and off the bottom of the bottom one. I have a plan. I'm gonna give you 4 cuts in here. And so what we want to do is we want to create a sketch. And actually, I can use the original sketch. I can use this original sketch because I want to create a cut. And that cut, I want it to come in. Well, we're going to do something cool. We're going to grab a point. We're going to do a midpoint. So you just grab on the edge and you just kind of roll down until you see a triangle. There's a triangle that pops up. Little triangle next to my cursor right there. And that tells you you're at the midpoint. So once we have the midpoint, we're going to grab a line. We're going to come across. Okay. We're going to go ahead and finish that sketch. We're going to turn on the sketch so I can see that line, because that is how much of a gap I'm going to do. So, we're going to revolve this and this. We're going to do it symmetric. We're going to revolve it around the center axis, but it's not going to be 360 degrees. I'm going to go, I'm figuring 10. Oh, that's way too much. Let's go 2.5. Not 250. 2.5. That's going to give us a little cut. Quite frankly, we can probably go 1 degree. Nah, let's go 2. Let's give her just a little bit. That's going to give her plenty of room to flex this thing, even if it's made out of hard plastic. Oh, Grant, you big dummy. You should have also grabbed that. And that now means we've got the cut. Are we doing things right? Ah, right. We need to move it, and we need to move it back so that the revolve occurs before... Now, see, guys, I'm going to go back and show this to you. You see how I did the revolve, but because the revolve occurs after, we still have this weird fillet that's going to pop in the way. So, we're going to grab down here at our history. We're going to roll our history. We're going to roll that piece back, and now it's gone. And what I want to do is I want to have 4 of these. So, we're going to go to Create, Pattern, Circular Pattern, and we're going to grab Features, because this is a feature. We want to do along the top axis here. And we want to do... I mean, 3 might work, but I'm figuring 4 might be better. I mean, an odd number is just cooler. Kenzie, give me a number between 1 and 5. Or 2 and 7, I don't know. Give me a number. And the process for my piece... it's going to be just like this. And for people that are wondering, I will put... I got to go to O-Light, because the lights that I have are O-Lights. So, I will tell you guys what these lights are that I'm designing for. And we're actually going to release these files to anybody that wants them. And coming soon, we're going to have a Patreon where you can actually get access to the real Fusion files versus just the STL files. And that's a pretty big deal if you're looking to make any changes for things on your own. Okay. Alright, I can't find my O-Lights. I'm gonna search for it here. Give me just a second here, guys. Interesting. I can't find them, but that's really no big deal. Kenzie says 5, so we're doing 5. There you go. So now we've got our pieces here. And, of course, again, this is done before all of that. So we got to bring this thing... I'm just going to move this out further so it's out of the way. Alright, I now have Kenzie's logo. I'm going to try it as an SVG, so we'll see if we can get that to work. So this is her logo. I need to save this as well. We're just waiting for stuff to upload. Now that we have something, we're going to grab the asset, and we're going to... Grant, you could have just done an insert SVG, you dingus. There you go. That's where I want it. And, of course, it's freaking massive. Justin, I think that worked out well, buddy. I'm going to shrink this way down. The thing with a lot of this is it's difficult to adjust the size later on. So I'm trying to make it as big as I can to get her what she wants. Okay, I think that happens to look pretty well. I might want to bump it down ever so slightly. Beautiful. Whoops, I am typing... Alright, can I grab these? I totally can. Beautiful, beautiful, beautiful. Alright. My brother, I'm trying to make it bigger to give her what she wants. Well, story of my friggin' life, right, gentlemen? I'm just saying. Alright, let's... Hey, look, we're doing this live, okay? Sometimes things happen. We're gonna kick these in ever so slightly. Maybe negative 0.6. Oh! Alright. Those little dragon scales are gonna suck so much. Oh, it's gonna suck to print, but let's do it. Whatever, we're here, let's do it. There you go. So I'm looking at about 0.6. I probably want to go a little bit more than that. Oh, I did 0.06. Yeah, no, we'll do 0.6. That's going to give it, well, some depth. Those are really going to suck. Boy, that's really going to suck. Hey, Kenzie. What is your favorite color? And I will say, I've got some really cool colors, which you've seen before. My color changing ones. And let me go to Big Grant so you can see it. Let's bring up Big Grant here. We got the orange, that when you put heat on it, Kenzie, they're either going to work or they're going to fail, and I'm just going to let them go and I can cut them off later. So you've got the orange, but when you put heat on it, it turns bright yellow. And we've got the purple, that when you hold on to it, goes to pink. Well, it did. I promise it goes to pink. Where's my blowtorch? Here's my blowtorch. See, anytime you want something to happen, it involves heat. See? Goes to pink. Problem solved. I do have a really cool blue. I was actually saving it for a company project. I don't know. Kenzie, do you want like a shiny blue, a light blue, or do you want a color changing? Let me know. I'm going to keep working on this. And actually, if we can make it happen, I am going to actually print this live for you guys right now. Alright. Hi everybody, Grant here. So the fun thing about these flex steel sheets, oh it's so hot. I gotta let it cool down. Let me cool it down and I'll pop it off on camera. This build plate is really hot. Screw it. I'm gonna turn off Octoprint. And I'm gonna bring up Big Grant. So I've got the build plate right here in my hands. And one of the things that is recently became a, I don't know the right term, like a point of topic for people are flexible steel sheets, because flexible steel sheets, that's it. And the part is off the bed. Honestly, it came out way better than I expected. When I saw how tiny the part was, I'm like, so I gotta clean up just a little bit. We end up with some stringing as a result of the filming process. That's no big deal. Quick little cut. Quick little hit with the blowtorch. Although, I'm not gonna use the big one. I'll use a micro torch. No, I'm gonna use the big one. It's gonna bother me. You gotta show perfect prints on camera, right? Here. I've done this so many times, I'm just used to using a blowtorch incredibly close to my hands. There you go. There's the part that we literally just designed, and we 3D printed it. Come on. Kenzie, what I'm going to do is I'm going to print one at TPU as well, and we'll get these shipped out to you so you can take a look at them. Hopefully, theoretically, I have them out by the end of the week. What is it, Wednesday? I can have these out by the end of the week. We'll have them out by the end of the week. Hopefully we can get them in your hands for your next competition. Should be a lot of fun.